Okay, I'm going to be navigating Sketch-a-Filt and showing you some of its features. I go to the command line and type Sketch-a-Filt to invoke the tool. Up it comes. Here's the GUI where everything, well, almost everything happens, although we do have a few subsidiary displays that come up. And the things we're concerned with primarily are between 0 and Nyquist, unless we have a complex filter that we're designing complex coefficients, in which case we would want to go minus Nyquist to plus Nyquist. I do a left button click because that's where how most things are done in Sketch-a-Filt, and I just draw it. Immediately I have a 63 coefficient frequency sampling filter by default, which is hugging quite well the red line. The black line is the gain of the filter I just designed, and of course as I make the target profile, the red line, more sharp, then it has a harder task to actually meet it with the 63 coefficients. The 63 of course translates into the number of constraint points I've got down here in terms of frequency, and these are spaced by 1 over 63. I can throw another design technique at this with the least squares. You see a different sort of shape come up, and overlays also in terms on top of the previous impulse response, which is shown up here. What's good about these two techniques is that we can happily go up in dimensionality without any loss of speed here at all, really. We can have a couple of thousand coefficients, no problem. Now that's very good for multiplier rich environments where you really need large numbers of coefficients. Other algorithms can be brought up, like the Remez. This is unweighted Parks-McClellan. If we want to do weighting, we need to use some other features, which I'll mention in a moment. And we can also then go to IIR filters. Let me click on an all-pole filter. Now you notice it was quite a strange shape here. This is not a case of really bad approximation. What's happened is we look at the impulse response, and it's become left justified by virtue of being an IIR filter. It's no longer centered in the middle, no longer a linear phase filter, and so the concept of smagnitude or amplitude or zero phase transfer function, which you can read about in some books, is not a particularly good way to display this. So I need to go to absolute value of that, and you can see the hugging is somewhat more sensible now. And if you want to read about this very, very important topic of smagnitude, you'll need to go into our help file. Now our help file is located up here across the top of the GUI with help Sketch-a-Filt, and this takes you really through all the features of the GUI and what's happening where and what the buttons are and so forth, and highly recommended. Another help file, although there are several, there's a big importance, is Sketch-a-Filt design examples. If you go to this, you'll see a number of problems which have been taken from the published literature and have been worked in terms of Sketch-a-Filt, and you can click on those and go see how with screen captures and so on, how you should use these to duplicate or in some cases improve results which are in the published literature. There are a number of other help files, for example, that tell you across two tools, this one and also the companion tool called Slifer, the various FIR design techniques that are available. And just tune down this, seems to be about 15 of them available off the shelf at the moment, and also IIR and so on. So there are some additional help files that are worth perusing up here. Just to finish the story here with the IIR filters, I bring up Yule-Walker, and it comes in with a different color. Brandenstein Umbehauen is one of the real stars of this tool. It's a really wonderful algorithm. Again, you should read about this in the help file and what its potent features are. Anytime I want to see how one of these filters is behaving in isolation, like Yule-Walker, I can click on this and see its pole zero, pattern, impulse response. I can go off and see its group delay, and a variety of things, and so I can sort of archive and document any one particular design. I can furthermore go to this see all filters, becomes a sort of a monster version of CPIG, and you can see them all overlaid, and you can toggle those out separately to look for differences and key features which are of some interest, and you can even get documented numerical results about all that. push it, up it comes, and you can see peak gain and all kind of things being calculated for you. Let me get rid of some of these. So at the top level we have IIRs, 3 of them, and 3 FIRs to give us quick look capability without any further ado. We of course have more methods available, but they're deeper in the tool. They're located in guest and user def, which I'll talk about in just a moment. Now we might want to change the shape of this target profile in some sort of way. I'm doing a right click in rubber band. I might want to set this to 0.7 units high, and there I go, and I'm able to do that. I can do various careful changes of the vertices of the straight line segments making up a profile by typing them in here. This then allows us to move away from sort of whimsical designs to things which are actually following some specification that the designer may have to go to, or the designer may wish to go and write an equation for this target profile. That can be done as well in MATLAB and can be imported through the file features here. There are lots of input-output capabilities, so you could, for example, import a target profile from the workspace. Your finished filters can be exported to various tools and so forth. Let me get a typical sort of simple profile brought in from this list of standards we have here: Hilbert filters, differentiators, Root-Nyquist filters, and so on and so forth. Those are sort of simple ones. Once we bring it in, we can of course make changes to it, and of course this technique will attempt to do the best it can. Let me give it less coefficients. That might be interesting, so it has a little bit harder time designing this. Let's see if we can measure the quality of this in meaningful terms. We've got a tool for doing this, quality measure, and what happens is it goes and draws a template around this, measures the stop band attenuation that has been achieved, the transition width between the distance between the pass band and the stop band, and here lots of specs about the pass band. And I can take this off to the side and then make some change, like for example I could smooth this profile a couple of times. Once is enough. I've got a much better fit than before, and I go and look now at the quality measure, and I've got different numbers. Well, in fact the dB is down so low, maybe I should go down and look for it. Go down to minus 60 or 60 or something like that. Yeah, there it is, just down below there. And those measurements are now different. I can put these side by side. I can carefully quantify the attractions of one filter over another. I can, back to this business of target profiles, I can make use of another tool to quickly get perhaps an exotic looking profile. This is the target profile calculator. I'm coming up with pictures of what I had in the original. I can do things to this, certain push button operations, like I can circular convolve this and put it over here. I can drag this one back, and I can get rid of the previous command, and I can say square what's in A and put that in C. Okay, so I can put together some sort of mathematical operations. Once I've done this, I can ship this back to Sketch-a-Filt by send profile. Which one? C. And back it goes, and it's in there, and I've designed to it already. So I can get mathematical descriptions for these things. I can make complex, as I mentioned earlier, by what's happened now. It's brought it in and it's clicked this off right here. If I click this on, this is the more usual situation. A change here echoes back as a negative frequency change, and I have real coefficients. If this is clicked off and I make a change here and no corresponding change here, then the symmetry is broken and I picked up a piece of an impulse response, which is imaginary. So across the top we have numerous things which we can do in terms of measurements, but also in terms of things like cosmetics, like I can turn these into bold lines, I can unbold them, and so forth. And change colors and do various things like that. I can export those curves to someplace else. But what I'd like to talk about now is the ability to bring in filters from the outside. I'll just clear the decks by hitting that. I could try to bring in a filter from the workspace or from a file of golden oldies. They're listed here. There's some sort of Dexy filters, and a famous one which has come up, and I can look at a Batman one here. There are lots of others which are available to me, and of course I can see their credentials here. And these might be useful. You can add to that yourself by editing and putting your own favorites onto that. And while we're talking about things that you can do, you can also define your own algorithms. Let's look at this. Here is a great list of things which are additional filter techniques, like weighted, the least squares filters, weighted, equiripple, and so on and so forth. And if I just bring up one of these, like for example, maybe one of my favorite, if I can find it, yeah, classic Chebyshev 2. I click this and I'm bringing up now one of those algorithms. If I look at this in DB, DB, I got to click it just right, and that's being grabbed by this, so let me get rid of that. That's just sitting there, useless operation at the moment. And here it is. This is now a very good filter with sideband levels. However, I can right click on this little edit box here and get a slider and actually change those side lobe levels. So some of these algorithms have interactivity built in, and you can do that yourself. You can take this great list of self-designed filters, add your algorithm which you think is missing here by editing and dropping in the M code down in here and following the rules which we set out and give you help to do. So this makes this tool a useful test bed for your own algorithms in comparison with existing algorithms which we've built into the tool, which there are quite a large number. So it's extremely flexible tool, enables you to get filters, to shape them up, to change them, and also, most importantly, to be able to archive them for traceability and to come back later. In fact, you can go into the if you say, okay, I've gotten this far and I really want to come back to this later on, I can save this session as a Sketch-a-Filt session, get partway through my design, come back tomorrow, reload that session and carry on. So there's lots of flexibility as to how you get your filters.